Kelvin said, if you can measure that of which you speak and can express it by a number, you know something of your subject. But if you cannot measure it, your knowledge is meager and unsatisfactory. In other words, all science is numbers. And when we can get down to arguing about numbers, then we have a nice way to decide, and there are ways in science that we can develop to come to an answer about how good the numbers are, and so on. P.J. O'Rourke is my favorite author, and he said, some people will do anything to save the earth except take a science course. And that usually means, after calculus or differential equations, you just kind of fade away from taking any more science. This is something else I found. I was a missionary in Africa and dealt with, belief systems and so on there, and this is what I've come to know, too, that people will believe what they want to believe, and scientists are people. And so, science is not done by anecdote or assertion. It really is done by numbers. Okay, don't you just love a bunch? I have a bunch of pictures later, so. But here are words, and here are some sound bites about the science I'd like for you to understand, especially right at the top. The evidence to me says there's an increasing atmospheric CO2, and that will enhance the greenhouse effect. This is simple physics, so that extra joules of energy will be trapped in the system somehow. How many, we're not sure, but extra will be, leading to higher surface temperatures. And that the Earth's surface temperatures have warmed a bit, but in a way inconsistent with catastrophe, and often inconsistent with the modeled enhanced greenhouse effect. I'll show something on that. Extreme weather events really are not changing much. And that was one of our conclusions in the last IPCC. Because you can count extreme weather events, and therefore you have a number. The background climate always changes, whether measuring sea level height, global temperatures, glaciers, whatever. There is no standard for these quantities, and thus there is no standard climate. The climate has never been what it was in the past 10 years any other time in history. It's that kind of nonlinear dynamical system. Okay, and any sea level rise, I think, will be very slow, as it has been for the past 6,000 years. It's been faster earlier. And sea ice has declined in one pole, but has actually increased slightly at the other. A little bit more on science. It gets more to this issue. Carbon dioxide, in my view, is not a pollutant. CO2 is plant food. Think about what it does in the atmosphere. In fact, about 1/6 of the current yield of food and fiber is related to the green revolution. Actually results from the extra CO2 mankind has placed back into the air, to our considerable benefit, I might add. All life depends on this CO2, and life developed, in fact, and progressed over a period in which there were several times more CO2 in the atmosphere than you see today. In fact, since I am not in Alabama, I can actually say life evolved and progressed over a period of which there were several times. Other human impacts, and this is also important, other human impacts can cause changes in climate variables. By the way, I appreciate the applause, but I'm sure later on I'll give you the opportunity to boo and hiss as well. So. What I want to talk about first is temperature, and two types of temperatures that we measure. One is what I call the deep layer, or the troposphere, surface to about 35,000 feet. We use satellites and balloons to measure this. Then there's the boundary layer, which at night is only 100, 200, 300 meters thick, and is measured by thermometers and shelters like that, and so on. We'll talk a bit about that. So the deep layer versus the small layer. And the first one we'll look at is the surface temperature data at three places. Well, first of all, the global surface temperature data. I have here the Hadley Centers, which does not have 2005 as the warmest year, in no tropospheric data set, and that's the bulk of the atmosphere. And none of them is 2005, the warmest year on record. But this is what you generally see, a rise there in the early part of the 20th century, a level or maybe a decline there in the mid part, and then since then, about the last 30 years, a rise in the temperature. Well, that record is made up of a lot of thermometers located around the world, and I wanted to check on places where I had actually been an observer. And there are three places where that has been. The first one is in North Alabama. And so I wanted to know, what is the real temperature here in this part of the world, where we have, in this region, we have a 40-kilometer diameter. We have about 14 stations. It turns out that that global temperature record I showed you before has none of those data. It only has a couple stations around about here. And the result, that I'm going to show you says that's probably not a good idea. I used about 20 times the amount of data to come up with a temperature record. And what you see here is what was published about 4 years ago. The blue line is what I came up with in a very rigorous exercise of reproducing a homogenized series. It actually shows the downward trend in temperature in the southeast. It's throughout the southeast, and as a questioner had indicated earlier, that is a fact, an observation. The temperature in the southeast has declined in the past 120 years. Alabama used to have a citrus industry in South Alabama. We have no more. It's too cold. So that, and the 30s were really warm. In fact, the warmest year, 1925, where in nearby Dayton, Tennessee, at Bryan College, there was a debate called the Scopes Trial. And when you see Spencer Tracy and Gene Kelly in the movie Inherit the Wind, and they're debating the evolution issue, they're taking off their coats, they're sweating, they're fanning. It was the hottest summer in the last 120 years in that region. Anyway, it is a declining temperature, and it shows some of the imperfections that are in that global temperature data set. Then to California, where I was born and raised, and actually began studying the climate very seriously as a teenager many, many years ago. And this paper, by the way, will be published, has a date of last week. It's published in the Journal of Climate. What is happening in California climate in the valley here, San Joaquin Valley? Here's the orientation here. And then versus the Sierras. Because I had thought the hypothesis here is something really different has happened in the valley, and that it's become an irrigated plain. Whereas before it was largely just very dry, especially desert-like in the summertime. Well, we have a control case. What's happening in the Sierras just right adjacent to it? And so going through, you see these things too. This is in Fresno County, where you go back about 100 years, and you see a glacier that has some ice mass there. And then in the current time, the glacier has really wasted away a lot. What we found is that, at least in this part of the world, glaciers are not very good thermometers, because what is happening in the Sierras is not a rise in temperature at all. It's basically flat when you look at this. Whereas in the valley, there is a very significant upward trend in temperature. And this is how you can find out why it is happening like that. These are seasonal temperatures. This is probably the most complicated of the charts I have. A seasonal temperature of the daytime temperatures in the valley. So that's winter, spring, summer, fall. Nighttime temperatures. And these are trends over this period. And this is what's happening in the mountains. Nighttime, or daytime, nighttime. And this is the difference. And what you see here is a very strong signature of irrigation in that the valley has cooling temperatures in the daytime maximum because of the evaporative cooling. We had evaporative coolers when I grew up in the San Joaquin Valley. But the nighttime temperatures have a very strong warming trend. So this asymmetric warming is, and that's not a picture of what greenhouse gases will do to the atmosphere. It's a picture of what other human effects have. Whereas you don't see that in the mountains at all. And so the difference here in trends is just tremendous. The valley temperatures are skyrocketing, really. And that is likely due to the extra darkness of the albedo, the extra water mass that has heat contact that it can absorb during the day and release at night and keep the air warm, and the aerosols that are strongly thermally active, so they keep the boundary layer temperature warm at night with all that pollution in the air. Let's go to Kenya. I was a missionary right here in Nyeri, Kenya, an observer. And by the way, this is Utah. I was a Baptist, so I wasn't part of the LDS thing, so I need to make that clear, I think. These are the daytime temperature trends, and this is a lot of work to get these kind of data, believe me. And we're taking it back to about 1900 and trying to understand the real problems in the data. But from 79 onward, these are the trends. These are the daytime trends. Blue is downward, red is upward, and you really see nothing there. That the Kilimanjaro airport has no trend. This part of the world, highly populated, has no trend. Now look carefully. Or maybe you don't have to look so carefully. Here are the nighttime trends. Okay? Daytime, nighttime. Now if there was only one big red circle or two, I'd say, well, it could be a data problem. But this is just throughout the highland area of Kenya. This is where the population has grown tremendously. And what do they use for energy? They burn wood. It's highland, it's cool, they burn a lot of wood. In fact, I have a slide later on, I'll talk to you about that. But this is a real good example, I think. The hypothesis here is that all that biomass that just chokes the cities and hangs in the air, especially at night, creates a sort of greenhouse effect because it swells with humidity and reflects or re-radiates the energy back down and keeps the nights very warm. So that's a good example. And again, this is not a picture of warming that's due to enhanced carbon dioxide. This is a warming that's due to sulfate or aerosols in the atmosphere. So what do we say about the surface temperatures? Is that they are taken in the boundary layer where extremely complex process-defined temperature changes. Changes appear to be different than those anticipated by greenhouse gas enhancement in several regions, but not all. So improvements, and another point is improvements are still needed in that data set. Every time I go in and get into the guts and create these data sets using 10 or even 100 times more information, I find the trends always become cooler than what is projected on the other, the more popular trends. Okay, what about the UAH satellite data? University of Alabama, Huntsville, what that means. I guess with a T it becomes Utah, right? This is the trend, the series and the trends that we have for our satellite data. And there is something confusing here. I see occasionally people saying that our satellite data has downward or no trend at all. And our stuff is on the website. You can download it any time, and we don't have that. It is an upward trend. And I think part of that is due to the enhanced greenhouse effect. But it's small, about 0.13, much less than what I'll show you in a minute. You see the big changes that occur because of El Niños, and volcanoes tend to cool the earth, as was mentioned earlier. And you see that right there. In fact, I looked at the daily values in February. It was heading downward again on global temperature. So this is the bulk atmosphere, where all those joules of energy reside. How good are those data? And there's been a lot of stuff in the literature, arguments back and forth and so on. But independent validation is always a good thing to apply. And if you look at the green trends here for the tropics, you see those are 4 different realizations that don't use our data at all. So they're independent from our data. The blue is the trend from our data in the tropics. This is a different satellite data set. This is the average of several model outputs. Now, if you were a modeler, which data set would you like to compare against? Well, you'd probably like that one because it's closer to where you are. None of these would be you would prefer. That is a part of the world that is very complicated. I've seen gradients of humidity in the upper troposphere of from 80% to 2% in 100 kilometers from the satellite data we have. This kind of feature is not replicated in climate models. They're very sharp, and a dry place in the upper atmosphere means that's a window where radiation just goes up into space. So where carbon dioxide might be storing or keeping those joules, maybe there are other places where those joules of energy are being allowed to escape at least a little more effectively. This paper will be coming out pretty soon, in which, well, what does it say? It says, in comparing 3 data sets, a very special balloon data set, our data set, and another satellite data set, is that our data set compares with the independent data almost perfectly in its long-term change over time. So this independent validation is what we really go for in science here. So what about the UH satellite data? Only satellite data set subjected to rigorous intercomparisons with independent data. It's the only one, and found to be highly consistent. Rates of atmospheric warming, global and tropical, suggest significantly less warming than the majority of model simulations. Okay? Now what about weather people really care about? This is drought and floods. We have no indication of an increase of drought or flood in the United States, which is the best monitored place for these kinds of things. But when we looked at the IPCC throughout the world, that was the same case. This is a meteorological event. I'm not talking about damage caused by drought or floods. I'm just talking about the numerical meteorological effect. Here are hurricane strikes in the United States. Now, I don't want to mislead you. This last decade here is only 5 years. Okay, so if we double that, say the number of hurricanes that hit the United States for the last 5 years, we just double it and say that's the decade average. We're about what we then have in the 1940s. But this indicates that there really is no trend in the type and strength of hurricanes that strike the United States. You know, what's really sad is that a hurricane Category 3 can strike, the United States and cause such havoc as it has in New Orleans. That's more an issue of people living 6 feet below sea level in a city than the weather. And as a state climatologist, I constantly warn industry when they come and they have $1 billion plant to build. And they have to have the right amount of information. And I say, you go, if you want to build that Gulf Coast site, think about it with 20 feet more of water. And that's not due to global warming or anything, but that's a storm surge, and it has mass and it has force. And but what has happened? The property values have increased. People are moving in. You know, it's just you can't get points across to people who want to live on the beach. And you know, you guys don't have any problem with that here in Utah. This was a very interesting thing about. There's been a lot about hurricanes in the past year or so, and I think the most revealing thing I have seen, because I'm a satellite guy as well, is that I think that increase in intensity that you've seen publicized is more an increase in the resolution of the satellites used to define a hurricane than it is the actual increase. We use the polar orbiters, which had the same resolution during that whole time. You have a whole lot more intense hurricanes in the early part of the record, and that trend almost disappears. Anyway, this is one about hurricanes that hit 3 islands, Puerto Rico, Jamaica, and Bermuda, in 50-year chunks, starting in 1751. And you see that when you add them all up together, there's actually a decline here. And I think that's real. I believe that if we had Gulf Coast hurricanes back that time, you would probably see an increase in the Gulf Coast hurricanes, a decline in these hurricanes here. And overall in the world, the number of hurricanes just doesn't change. It's about 95 a year, and that's been constant for the amount of time we've been able to measure. Tornadoes, actually, if you want to put a trend to that, they're going downward. Oklahoma, where all the people go to school there, graduate school, because they want to chase tornadoes and stuff like that, had a terrible time in 2003 and 4. They went tornado-less, a record period of over 100 days. And so this decline in tornadoes is interesting. Now, have you seen a paper that says, a news article that says global warming causes a decrease in tornadoes? No, the issue is always, what's the dramatic event and how can we tie global warming some way to it in the headline? This is what Utah really needs to worry about right here. That's a tree-ring record of western U.S. Precipitation. It's been pretty good here the last century or so overall. But there are periods of multi-decadal droughts when you go back the past 2,000 years. And this is where I think you can make some impact. You can go to a policymaker and say, forget about human-induced climate change. This is a variable climate. We are vulnerable to extreme periods of drought naturally, decadal kind of scales. And you can make an impact, I think, on water policy and so on like that. And as someone who lives in a place where we have water that falls from the sky all the time, so much so that Alabama uses 1.2% of its freshwater resources. 1.2%. I think if you're growing corn or alfalfa or something like that out here that takes 4 feet of water a year, bring it back to Alabama. We have the water crawling free from the sky, and it will free up the water for the environmental concerns and the urban concerns you have here. That's a big issue, believe me. Trying to make that happen, I should say. But we are. So extreme weather trends are ambiguous, not definitive. Damage will increase because there is more wealth and property to damage. See that number 2 point? Damage will increase, period, because there is more wealth and property to damage. Okay? Natural variations indicate future situations with or without human enhancement of greenhouse effect will likely cause significant stress, suggesting a very careful appraisal of the vulnerabilities to which you are to this variability. Now, what can we believe about the future? There are ominous signs that the Earth's weather patterns have begun to change dramatically, and these changes may portend a drastic decline in food production, with serious political implications for just about every nation on Earth. The drop in food production can begin quite soon, perhaps only 10 years from now. The evidence in support of these predictions has now begun to accumulate so massively that meteorologists are hard-pressed to keep up with it. The central fact is that after 3/4 of a century of extraordinarily mild conditions, the Earth's climate seems to be cooling down. That was what Newsweek said 30 years ago. be very careful of what you see in the media and what's reported. I got a lot of stories, but I only have so much time. How does even scientific assessments like the IPCC tend to fool or misrepresent the facts, the numbers? This is from the IPCC in a part that I was not involved in directly. But this is Northern Hemispheric sea ice extent, and there were two model results that came out in the 2001, and this is the Northern Hemisphere sea ice extent. So we're up in the Arctic, north of Canada. And this picture was shown essentially like this. And there was a box, big page and a half actually, that says the simulations of sea ice extent last 30 years are in good agreement with observations, lending confidence to subsequent projections. Now, what was the simple question that should have been asked? Well, what happened in the other hemisphere? Both models used there showed a declining trend when the data available to us at the time, the green, shows an increasing trend. Why was not even mentioned? Because, and I said in many of these meetings with people in the other chapters and so on, there was a real sense of those other authors, we have to make this dramatic so that we can have the United States sign on to the Kyoto Agreement. I sat at a lunch table one time where that was specifically stated. I testified in Congress before with John Watson right there, or John Houghton, and they would advocate the Kyoto Protocol, for example, and yet serve as IPCC heads and so on. I think even in the IPCC, you find this kind of mingling of policy and agendas that will not give you the numbers, because all science is numbers. Now, what about the southeastern U.S.? These are the latest IPCC climate model results. These are what the projections are for temperature over the last. This is trying to reproduce the last century or so. These are the observations on the left, the blue. And these are all the results from the climate models, which none of which, in any of their realizations, indicated a possible downward trend in the southeastern U.S. temperature, which is real. And I like what Igor Sikorsky said, and this is back in the days when engineering students were only male. Okay, so forgive him. In the course of your work, you will from time to time encounter the situation in which the theory and the facts do not coincide. In such circumstances, young gentlemen, it is my sincere advice that you earnestly respect the facts. This is a story that I can't go into. It's the same issue that Warren Washington showed earlier. I was quoted in it, and I'm familiar with how that article got put together. I'm going to skip the stories because of time, but I will show you this. The tone of Time's package is decidedly alarmist and aimed at bringing pressure to bear on the Bush administration. I have this in writing from the reporter who wrote that story. Silly me. I thought Time was a news magazine. You are not getting the story, the scientific story, I should say, if you have a Time or Newsweek or newspaper understanding of this issue. It is so complex. It is so big. And our ignorance about it is a lot greater than we like to lead you on about. Let's go to the policy, because I'm often asked to do that, because when I lived in Africa, I dealt with people who were dying because of certain policies and so on, and have been asked to comment on that in various times. The United States is a pretty efficient country. If you look at how much energy we use per stuff we make, we're down here on this list right there. We produce a lot of stuff for relatively small amounts of energy, and that is going down. The amount of energy we use to produce stuff is going down. It's about half of what it was in 1970. 15 minutes to what? To the very end? To the end of the world. Oh, no! Okay, that's basically 5 more minutes of talking and then 10 minutes of questions. Is that what that means? Okay. What was I saying? You see, in a market economy where people have freedom to do things and to innovate, energy is a cost of stuff. And so we try to work that out. And that's why a power company is working out ways to get energy to you as cheaply as possible, and the price of it has not gone up That is a tremendous advantage for any economy, not to have an increasing cost of energy. And so that means the amount of energy we use actually goes down for what we are able to produce. And this is an interesting slide, and I made this before the Bush administration even was elected. I've only updated the numbers, but this slide was made a long time ago. The United States produces 23.1% of the world's CO2 emissions. We produce 28.5% of the stuff people really want. Those are like agricultural products and research. We feed people. Medical advances on every front. We fix people. Kind of get the idea here. This is for senators, so, you know, the blue is what you try to get. Technology unimaginable. We fulfill people, invest in and aid the world. We fund people. The defense of democracy. We free people. Obnoxious entertainment. You know, we offend people, but that's what we produce. That's what we produce, and that's what the world wants. And so our CO2 emissions have made the world a far better place than it would otherwise be. Think of energy as a coin. And I think a lot of people, perhaps in this group, look at the tails and see only the bad stuff. But if you drill a hole in that to say, let's take out the energy, you better remember what happens on the other side. Because energy use has probably contributed to the fact you're even alive today. Because in the United States, you know, the line forms behind the United States when it comes to innovation. And we are going to be the ones to lead to the next sources of energy. When I was a missionary in Africa, I taught physics and chemistry right here. This is Peter Moriyuki taking the temperature in Nyeri High School. But that's energy in Africa. That's a forest. The forests are being destroyed there tremendously, just so rapidly. Women would get up in the morning, you know, never had a chance for education. Get up in the morning, walk miles to the edge of the forest, chop down the trees, lug it back. These things weigh 100 pounds. I couldn't do that. But these Kikuyu women, 4'9" on average, would lug that thing on their back. Each of these women have a baby on the front and other stuff on their head. And they're hauling this stuff home for use inside. And this indoor air pollution, if you burn wood inside a hut like that, it is so noxious. Eye disease, respiratory ailments, and so on. UN estimates 1.6 million die a year. If you want to do something about that, you build a coal-fired power plant. You save the forest, you provide electricity, you relieve burdens for people so that they can be educated and become part of society. And Kenya is one of those countries where half of the gray matter is hauling wood and water. I'm talking about the women. When you have a country where you can use all of your gray matter to fix its problems and develop its economy, it really changes the world. So energy means life. Energy used directly is directly related to health, security, and general standard of living. Making energy available and affordable is a key step to improving the lives of real people. And I'm talking about people that have names, that have children, who want their children to go to school, and who want their children to become something that they are not farmers or so on. So energy production will rise. That will happen. Democratically organized societies rarely agree to reduce their standard of living to achieve ambiguous and ineffective goals. I mean, we knew before Kyoto was signed that if it were followed, it would be, we couldn't measure it. And I'm one of those people that measures this whole system. We couldn't measure the impact of Kyoto. It's so tiny. And Tony Blair recognizes this in a famous quote. He said, I think if we're going to get action on this, we have got to start from brutal honesty about politics and how we deal with it. Truth is, no country is going to cut its growth or consumption significantly in the light of long-term environmental problem. So if you are really alarmed about the CO2, the extra CO2 that we are putting back into the atmosphere, in the real world, about the only thing you can advocate is just a massive nuclear power building program. That would cut CO2. But any of these other alternatives are just fiddling on the edges of the growth that's going to take place and is taking place. China, I understand, puts in a coal-fired power plant per week now. That's how rapidly they are growing. Per week, one new plant a week. And do you know what kind of environmental controls they have versus ours? But I'm optimistic. I am very optimistic. You know, my son is a PhD graduate student in physics at Maryland. What these students have today and what they are doing blows my mind. I mean, when those of us on this front row were graduate students, We played pathetically with cards and paper tapes and slide rules, and stuff. It didn't have calculators. What they have today, they're going to solve problems. They are the innovators. And so I'm very hopeful about that. Now, just as the 19th century transportation was dehorsified in the 20th century, I think 20th century energy production will be decarbonized. I hope so, because my Ballard power stock is in the tank right now. And if fuel cells come around, I hope I can break even. So the real surprises, I think, will be in the advances in energy production and use. And I have one final slide. I like cantankerous people who have these strange things they say. Walter Monk said, "We are 20,000 years past the last glacial maximum, and under normal conditions, 80,000 years away from the next glacial maximum." Was it not clever of our civilization to learn how to release greenhouse gases into the atmosphere to delay this oncoming catastrophe? Okay, I'm done. I'm finished. Is that it is not going to be as rapid as the catastrophists like to claim. Now, if you are one of those persons, then you could solve the carbon emission problem by massively going into a program of nuclear power generation, because the world is going to get its energy. It just will, because it makes life livable. Now, I happen to also believe that innovation, which is this country's strongest asset, and it's just wonderful to see all the female representations of our species here, because that doubles our ability to solve problems. And we tried so hard in Africa to get the parents to let their girls go to school. You don't know how hard we tried that, because that's a real key to countries like that. That we will look back 100 years from now and say, wasn't that quaint? They burned carbon for energy. That's the progress of science and of economies, that new ways and cheaper ways to create energy will happen. And there will be ones that don't need carbon, I suspect. I hope. And then this problem will go away. Or be much reduced. Yes, ma'am. This is easy. I was asked if I attended the talks yesterday, and how would I respond. No, I was at the National Academy of Sciences yesterday in a rapidly called meeting about climate change and so on. So I did not see the talks, and I have no comment, I guess. Yes, sir. I'll come. Could you repeat that? I didn't quite catch it.
When you are having discussions with other scientists in various parts of the spectrum of warming, what are the specific aspects of data that you understand that you find just about everybody in agreement on? And where do you find those critical?
Okay, in discussions about global warming, where do we find agreement among scientists, and where do we find disagreements? The agreement is clearly that carbon dioxide in the atmosphere has risen. No question about that. And it's humanly caused. I don't think there's any question about that. The temperature of the last century has risen. I don't know anyone who would argue that. Why? That is where the interpretation comes in. Models are able to reproduce what they've already seen, by the way, reproduce the temperature of the past century or so with certain aspects of human-induced changes in there, but I would say I would have some questions about that, because I know processes in the boundary layer that are not included, but that really do have a big impact on temperature. And so the why would be the issue, I think. Okay, yes, ma'am.
If you go back to the, I think it was one of your early illustrations here, and you, if I understood it right, you said there's no way anyone can say exactly that. So I'd like to know, even though you weren't here, I'm sure you've heard my husband and others speak before. So is it warmer or not? And the other thing you said that seems to be inconsistent with virtually every other speaker was that there's historically, geological history, there's been higher levels, many times higher levels of carbon in the atmosphere. And that's, unless I misunderstood everybody else, that's also in conflict. So those are two numbered things that you could please elaborate.
Okay, a question about how does the current temperature record compare with the past?
2005.
Oh, just the 1 year? Oh,
Last decade.
oh,
Take
okay.
The last decade as being the warmest decade because we heard repeatedly that it is the warmest decade, and I thought I heard you say no one can say that.
Okay, I didn't say anything about a decade temperature that I recall. So the question was about the decade. For those of you out in the ether world, wherever you are, the question was about what about the last decade. If you look at that time series, I think you would have to say the last 10 years would be, the average of the past 10 years would be higher than any other 10-year average. Yeah, that's
I guess you
obvious.
said about 1 year.
Yeah, I was talking about 1 year and about the tropospheric temperature, I think. Second question was, the geological scale.
Yeah, on the carbon in the atmosphere.
It's funny. The NAS panel that we were just convened to deal with deals with paleoclimate evidence. That the CO2 was much higher in the atmosphere in geologic time, we're talking about millions of years, 50 million years ago or so, and that the temperature was hotter are two, that's another data point. CO2, temperature, it does have a relationship. We might go back, though, I would hope you remember that 130,000 years ago during the Eemian period, the sea level had risen to 6 meters higher than it is today. So with or without human-induced climate change, in this interglacial, we should expect, at least should not be surprised, that sea level continues to rise at least that much. And Greenland was much smaller, is what we heard this week around that time. So while glaciers can be good, I think in the polar regions they're pretty good thermometers, but the things that affect them on tropical areas and so on are quite different. Let's see. Let me get one more way back in the back here. Yes, ma'am. I didn't see the talk. I don't know what kind of ranges or concentrations were being discussed. What I've seen is the literature on ambient levels versus, say, doubled CO2 and so on like that, and there's a very consistent picture of greater productivity. Well, it's because CO2 is a fertilizer, it's plant food, so if you put more of it out there, the plant will respond with greater growth, not use as much water, so on like that. So I don't know about the studies that, I'm sorry.
Thank you very much.